So in this tutorial, I'm going to show you how to integrate uAim with an animated asset like this turret system, which means you have to manipulate bones to apply the rotations to. So to do that, I copied this asset, or maybe I should show you how it looks like. So you see, it's an animated turret. I can also move it around. It's still going to work. I can rotate it. And it still aligns to hit the targets. Even though it's still animated, as you see. So that's going to be the tutorial. By the way, this object here, I got it from here. It's this here. If you are interested in which asset it was. And yeah, to start, I just copied this simple gun blueprint from engine plugins, uAim content blueprints. I just copied this over to my project in here. So that's the blueprint. And I deleted all the previous meshes from the turret system. So it was empty. So it was basically like the empty one, just that it was a derived class from the empty one. And then I attached first this mesh here and then this here. But actually, oops, sorry. Actually, if we open this and if we remove that, that's actually the base mesh. So it doesn't look so good like that. But if you apply all the attachment, it looks much better. And that's what I did to apply the attachment. I just copied that from his blueprint. So he has a blueprint where he has this already attached. And in the construction script, he has something to automatically attach it. So for the attachment, because you may be interested to get this cool attachment too, in case you use the same mesh, you just select everything from here and copy, and then you paste it here, and then you get it. And the same with the construction script, and just replace the parent with your parent, which is a different one here. And then you get all the attachments. And I did apply a rotation here to have a different forward vector. But yeah, you can also set it to 0 if you don't like that. It doesn't really matter. It's still going to work. So that you see, it's still the same. It's just a different orientation. But I prefer a different forward. And yeah, actually, if you just attach this here, nothing is going to work, but you got an animated object. If you look at this, you see this turret system is animated. The head is also animated. So I'm going to show you something now. That's the event graph of this blueprint. And I'm going to change something with the pause after each target swap, just to show you that it's animated. And then it switches from animation to targeting. So that's how it looks like. If it stops, it's animation, and then it goes to the other mode where the turret aims at something. And that's how it looks like that, switching from an animation. And yeah, the head of the turret, if you look at that, it has a lot of movement. That's why it looked like it looked. So it can look at this direction and then bam, auto snap to something on the right. Yeah, this is just the logic that I implemented here very quickly for showcasing purposes. So maybe we start even with that logic, because I added this tick function here to swap the targets, to make this effect of changing targets. And if you want to use this in a real games scenario, you are going to have your own logic in here that does something similar. So if I have no target, right? If I have no target, I search a target, and then I set the target and I start the behavior. So in the next tick, because I have a delay here, in the next tick, I have a target, so nothing will happen, right? It will jump to this, nothing will happen, but the delay had been already triggered, which means after 2 seconds, it's going to set the target to 0 in here. So here I had the other behavior with the stop, so you see the animations, and then a delay again. But in this behavior, I set the target to 0 or to null, not to 0, to null, of course. And then because it's null, it will jump here and start again with a new target, which is randomly selected. And that's the behavior. It just switches from one target to another without the in-between step of the animation playback. And if you drag it to here, I stop the behavior, then it goes back to the normal animations where it has this head, this wobbling head movement, and then after 2 seconds it's again switches the target to null or sets the target to null, and then it will jump here again. So, but let's use this one. So that's the very simple logic. All right, so you can replicate this logic for testing purposes before you, for example, implement your own logic in your game in the way that you need it for your game, right? So let's move on. So that's the base. Then if you select the skeletal mesh here, you will see that's the mesh, and it has user animation blueprint, and here's our blueprint, animation blueprint. So if we go here and open this, this is actually, I'm going to make my audio, I'm going to shut down my audio because otherwise you hear this turret animating around. So if you look at this, what we have is, let's go back once again. If we look here, right, we have yaw, pitch, and an aim arm, right? And right now it's animating, which means you cannot configure this correctly. And for that, I don't know how good you are with Unreal and the animation graph and all of that. But in the animation graph, that's animation graph, there's a main state. And in the main state, there's an idle. And there's a pose as well. This is a static pose. So if you apply that, and if we look here, actually we can close this because I explained that already. If you look here, I have here the arm configured to be here so that it shoots from there. And I just moved it by hand. Then I placed the pitch here. Actually, if we look at the bone structure, the bone that I really apply the rotation to, it's this one. It's not even in the center, but it doesn't really matter because the rotation is going to be the same. I mean, you can place it exactly at the bone, but in this case, you can do it, but it's not going to change much. Or it's not going to change anything at all, because, like I said, the rotation is going to be the same anyway. You are going to have the same pitch rotation for this to hit something. So I placed it, where am I? I placed it in the middle, but if you look from the side, you see it's in the, I don't know if you see it, but this is this round shape, it's where it's rotating from, right? So, that's where rotated, where I rotated, because if you look here, you see where it is, it's here. And from the side, it's here as well. So this is important to get right. That's the pitch. And then we have the yaw. And the yaw, if you look at that, maybe let's switch back to perspective. I placed it directly in the center of this round. Oops, I'm too fast here. Of this round plateau. And I did this. It's not even completely in the center. And funny that you saw that it was an issue with updating. It was in the center probably with an issue with updating of the animation. Don't ask me what this was, but it has nothing to do with the code or anything. That's just Unreal sometimes doing fancy things. Anyway, this is in the center of this round thing here. And this is where you have to place your stuff manually. So when you get the mesh, you just move this around so you get it in the right position of your custom turret system. And then, yeah, you compile and you get that. And then let's go back to our animation blueprint. So in here, what did I do here? First of all, you have to know that we have to sync between our pitch and yaw and the bones of this skeletal mesh. So that's what we have to do here. And first of all, I get the owning actor, so I don't call owning pawn because this is not a pawn. It's an actor. But if you want this to be a pawn, you have to copy the empty base. So just a slight or a little information for you if you want to do it differently. If you copy that, it derives from this, right? But this derives from actor. So if you want your object to derive from pawn, you have to copy the empty base and do the same there. That's just how it is. But in this case, I derive from actor, so I can use the derived class. And in here, what I do is I get the owning actor, and then I cast it to the turret system, and then I save my reference. And I say if I have no reference to my turret, because when you don't press play and something like that, it still jumps into this blueprint and then it causes maybe some weird errors. And to avoid that, if you have no turret system, you say has target none. This is later being used to swap between animation, how should I say it? Animation states. So with that, you change animation states depending on if it's set or not set. I can show you that. If we go to the main state, animation graph. So here we use the target. If we have a target, we use some aiming stuff here. And if we don't have a target, we use the main state, which is just the main state cached here. And then we cache this and we return this. But I'm going to explain this in detail during the tutorial. So let's go back to the event graph. And in the event graph, we want to update our bounds, right? And to do that, so before I say this, of course, this here is a variable. If you look at the variables, we have here the has target variable, yaw rotation and pitch rotation variables. And also the turret itself was a variable, of course. Just to say it in a complete manner. So in the updates of the yaw, what we do here, that's a little bit complicated. So we cannot just take the yaw and set the world rotation directly, because we have different bone orientations or different bone spaces. And this may apply to you as well. So you have to check your mesh here. So the yaw is actually this here, it's the part 18. And if you look at that, the forward vector is the z vector here. And the up vector is the negative right vector. If you look at this, right, you can compare it to the bottom here. So yeah, it's different than it should be. Now you can't really compare it to that. You see it anyway. You know that this is your forward, or should be your forward, right? And yeah, it's a little bit, it can get a little bit complicated. So what we want now is we want the rotation and we want the forward vector of the rotation. And then we want to make a new rotation, which is converted to the space required for this bone to look in the right direction. Because here I want the up vector to look in the forward direction. So we get the forward vector and we say we want the C, which is the Z is the up. This is C is where we want to look at. So the positive Z vector, we want to set this one, and we want also an up vector to be configured to have it aligned correctly, because you may rotate your object in your game, you know, and stuff like that. So we need an up vector as well. And the up vector, I got the up vector from the parent bone, and it's in this case the right vector of the parent bone. So why is that? So the up vector here should obviously be the negative right vector. Or let's say this vector has to point down, right? You see it here that it's pointing down and not upwards. It's difficult to see, but you can see it here. And the parent, let's make this like that. The parent of that is part 1. And if you look at part 1, this down vector here, which should be the up vector for that, because that's just how this system is configured, is the green one, which is the right vector. You see? So what I did here, I just get the right vector and say that's my y. And then it's going to work, because that has to be my y. If you look at the part 18, we need as y vector this downward vector here. And it's the same for part 1, but we always take the parent, so that if we rotate stuff here, it doesn't get some numeric errors or something like that. So that's why we get the parent. And then we set the yaw rotation. Oops. Let's compile and save. And then we set the yaw rotation after doing that. So you see this is part 1. Skeletal mesh, it's in world space. Everything is in world space. This is also in world space. So you can copy this here if you need that. And then we do the same for the pitch. So we also get the pitch here, and then we get the world rotation. And here the parent is part 18. It's a little bit different now. And we also negate the forward vector, and I'm going to explain you why. So if it opened again everything, I don't know why. Sometimes Unreal just does what it does. So here is the part 19 that we want to apply the pitch rotation to, right? And if you look at that, the forward vector, the look at vector, is the negated x vector. You see, it's the negated one. So that's why in here I take the forward and negate it. And this is where I want to look at, because it's just inverted. That's just how this bone structure has been configured. It's inverted, so I invert it to look correctly in the right direction. And then what I say here is I make a rotation from X and C. And C, in this case, is from the parent, the right vector. Let's check it out. If you look at C, C is the up vector here, right? You see it's the up vector. And the up vector from the parent, which is in this case part 18, it's the negated right vector from that, because it's pointing down. You know, green is always the right because it's the y. And this is why I get from this the right vector, and then I negate it. I have to negate it as well in this case to apply it as the c vector, the up vector of this rotation. And then I set the pitch rotation. So with that, I get my 2 correct rotations, and I say if it has a target, the log-on will be true, and otherwise it will be false. So this, if it has a target, this is true. It has a lock-on target, and it sets that. And that's this update here. So with that, you are going to get all the values that you need, the correct values. And if we go now to our animation graph, let's see what we did here. First, I created this main state, and I cached the main state. If you don't know how to cache, you just drag from here and create a cache variable. And if you look here, nothing that really happens. It's just an idle. And in this idle, now I have this pose animation, and I'm going to connect the walk animation here just to make it have a dynamic animation and not a static one. And that's basically what this is, or what the main state is. And then in here, I switch, like I showed you before, with this here, with this blend poses by Boole, I switch between the normal animation that is being played here and the animation but with aiming applied, which is being applied here. So I switch between them. I have some transition time. So if you want shorter or longer durations to react or to have for the transition, you can change these values as well. And then I save this in a cached variable again, and then I take the cached variable and drag it to the output node here. And now let's have a look at the logic, how this all works. So we get this cached main state, this one here. It's the same here as well. And we say local to component space. And then in the transform bone node, we set the your rotation. And this is, if you look at that, it's part 18. It's a bone called part 18. You can set the bone here. This is what I did. And you also have to set this to world space. I know this is local to component and all of that, but in the end you set this to world space, and then this has to be world space. And this is what we did. And this is what we apply, and the rest we ignore. And if you look at the settings here, we ignore the translation and ignore the scale. We just set the rotation and replace existing. I mean, there's other stuff, but no, we replace it, of course. The same here for the part 19 bone. This is for the pitch rotation. Part 19 is configured. This ignore, replace existing world space and ignore. So we have for the rotation, world space and replace, and that's what we need. Then we go back to local. And this is our input for the blend pose boolean. So it's not really that complicated doing stuff like that, but yeah, you have to know that you have to do it, you know. And this is why I'm making this tutorial for you guys. So if you want to have an animated system, turret system in this case, you can do it this way. You just override the bones and blend. And because this is a paid asset, I cannot include it in my sample projects. Otherwise I would have included a sample like that, but I just don't have an animated system as a sample, and that's why I'm doing this as a tutorial, and you will have to more or less copy this content if you need it from this video tutorial. So actually, I think that's it. I think we covered everything. The conversion to the correct spaces, the boolean to swap between animation and between aiming, the animation graph with how to apply the rotations. And this is the result that you get by that. So let's add some sound again. And there's one more thing I would like, let's pause this, I would like to show you. Changing this directly here in the editor, or changing values while you are in play mode, for whatever reason, I don't know why, but for whatever reason, it can create some weird behavior. That is just not right. Unreal is kind of buggy. In this case, I don't really know why it's buggy as it is. But if you want to change targets and stuff like that, it's more safe if you do it in code than if you do it with these editor tools. I mean, you can do it before you start, but after starting, changing these values will always create some weird issues. I don't know why that is. It's just an Unreal thing, I guess. And yeah, that's why I changed these things here automatically. And you will have your own logic anyway, how you target at something, you know. Every game is different and you want your systems to be different. In my samples, I used some triggers to detect the player, but you may want to have some raycasts and stuff like that. So it is very gameplay specific. And I may in a later video or in a later update add some additional functionalities where some more gameplay functionalities are implemented that you could also use, like for example these visibility checks for the turrets, not only for shooting and things like this. For example, for the player, I have a system like, sorry, not in this sample here because this player is just a default player controller, but this is not the tutorial. Sorry, the tutorial basically stopped here or stops here, but I'm still going to show you that. What I'm going to show you now. For the player, I have already implemented this system. If I target with the player like this, and I can move, you see, it already has an implementation which has visibility checks. So if we remove this wall here, and we go back to play mode, and I move outside, you see I can target these things here, but if I am here, I cannot target. I can press, but nothing will target. And here it can see this thing, so I can target here, and it keeps the target because I implemented it that way, that the targets stay, to not have continuous raycasts. And if I remove it and I press it behind the wall, it's not going to work. So it has visibility checks for the player, but the turrets I didn't implement this, a logic like that out of the box, because you know all these things. This should be in your repertoire to do it anyway, because you have to write a game, you know, and when writing games, you have gameplay specific logic, and there is no asset in the world that can cover all different gameplay types. And yeah, that's why I implemented the things, so you can have a look at them, but not like 1,000 different systems that you can drag and drop and use out of the box in any game. This never works, you know. But the systems are so stable, and that I implemented are so stable and easy to use, that you should be able to do what you need to do. So, and now I really end this tutorial. Thank you very much.